Welcome to Earth Operations. I'm Ty Taylor from the Operator's Manual for the Planet, and in this tutorial I'm going to show you how to get started with R and RStudio. I'll first show you what is R and why should you learn to use it for your data analysis. Then I'll show you how to download and set up R and RStudio on your own computer so you're all ready to get started. And then I'm going to show you how to import your very first data set into RStudio and start playing with it. Feel free to use the chapter markers down below to skip to the section that's most appropriate for you. First, why should you use R? Let me just breeze through a few examples of the kinds of things you can do with programming in R. This is a cool example of a figure that contains a huge amount of data. This is something like over 280 tropical forest sites. And each one of these squares shows the distribution of leaf area, so the amount of leaf area at each height on the y-axis. Dealing with this kind of quantity of data in any point-and-click program would be very laborious, but in R, once you have the code generated to make just one of these plots in one of these squares, it's trivial to expand it out to 100 sites or 1,000,000 sites. R can also do geospatial analyses. Here's another example also from Marielle Smith showing the distribution throughout the Amazon basin of water table depths, colored in the map on the left and then analyzed in terms of their relative areas in the graph on the right. So R can also do geospatial analyses and it can make beautiful graphs like these ones. Lately, I've been working in R. I'm showing you RStudio right here, and in the bottom is where R, the program itself, runs. And I've been working with this data set that I call OCK. I'll show you the first few lines. This is tropical tree species occurrence data. Here's the species, and it shows where each one was collected and what date. And this data set has, let's take a look, over 5 million records in it. Imagine analyzing that in Excel. No chance. What I'm doing with this data is running a bunch of big statistical tests and then mapping out where species of a particular kind of trees occur throughout the whole global tropics. So R is good for working with enormous data sets. In fact, programming of some language or other is the only way to work with enormous data sets. But R is not just good for massive data, and it's not just good for statistics. People think of R as a statistical program, but actually most of the time you spend in R is just working with your data, visualizing your data, exploring your data. Let me show you another example with a more simple data set. This is an example of a data file that comes from some sensors that we have installed in trees, and they're collecting data constantly every half an hour for months and months at a time. The raw files that come out of these sensors are a mess. They come with all of this extra header information, and you have multiple data sets stuck together with these big gaps with more extra header junk between them. So if I was to try to analyze this without code, I would need to manually go in and remove all of these and deal with things like these special characters that might cause problems when I try to run analyses. And that would be super time consuming to do with every data file that we download. So instead, I built a handy function here that cleans this data automatically for me. So every time I get a new data set, I can just come in here and I can run this for loop, which contains the call to that data cleaning function. And it loops through all of the new files I've called in, cleans them all up for me, exports them in a nice clean format to a folder with clean files. Then I can call them in, bind them all together, and analyze them, all without doing any actual work. I just run the code. Then I can use another handy little function here to easily take a look at the data that's being developed from these sensors. Keep a watch on this folder right here, and what I'm going to do is run this for loop, and it is automatically going to generate a figure with data for each month from this sensor. We'll take a look at one of these, and here's the full time series of data from that sensor. So I can see how the sensors are behaving, easily check in on how the trees are behaving. I can customize my call to that function and look at just a few days at a time, so I can zoom in on any part of that time series. I'm just gonna go here and I just wanna look at one day of data. So I'm gonna go from December 11 just to December 12. And there we go, we've zoomed in on just a single day of data. This gives you a flavor of the kinds of creativity that you can apply when you know how to analyze data with code. Now, why should you use R instead of some other coding program like Python? Hey, Python's great, it can do a lot of stuff. R, though, is specifically designed for data analysis and your eventual statistical analyses you want to do on your data. It's super flexible, it's open source and freely available, and a lot of people use it for data analysis, so it's easy to send your R scripts or your code back and forth to collaborate on projects with people anywhere in the world. What does R and RStudio look like? I've been giving you a flavor of what these things look like here. R runs down in this part in the bottom. RStudio gives you these several windows to work with, like this plotting window, and up in the left is a script window. A script is basically a document that contains your comments or your notes and your code. And you can run that whole script and R will ignore the notes and just run the code. You can make these things nicely organized with section headings and everything, like this example from the tutorial file to which you have access in the notes below the video. And you can think of this script as a story that describes the sequence of events that you want to have done to your data. Imagine being so unconstrained in your analyses that you're not limited to pointing and clicking on buttons and menu options in a program, but instead you could just write out the ideal sequence of events that you would like to perform on your data, no matter how simple the data is or how complex. If you can translate that story into the R language, then R, the program, can make that story a reality. You are totally unconstrained and limited only by your creativity. That's why you should learn R. Next, let's get you started downloading R and RStudio, and let's get your RStudio all set up properly. You can go into YouTube and click the gear icon, go to playback speed, and you can change the speed of this video to 0.75, 0.5 even, or 1.5, 2x. Just go to the browser that you like to use most and type in a search for download RStudio. RStudio is one word. Enter that, and one of the top options that you see should be from this POSIT site for RStudio Desktop. Click on that. Scroll down a little bit, and you're going to see options for installing R and RStudio. These are two different programs, but R runs within RStudio. So first, let's download R. Click Download and Install R. It's going to take you to a page with some options, including the download button for the Mac and for the Windows. I'll show you with a Mac first, and then I'll give you an example from a Windows machine. Okay, so download R for Mac. Now there's a few options here that might be relevant for the latest Macs with their new kind of processor, the M1 to 3 processors. You want to use this download link. For older Intel processor Macs like mine, we use this download link. So put that somewhere like in your downloads folder. This is just for the installer. So save that. Go ahead and click on it to open it up in that window, or If you don't see that like you do in Chrome, you can just go to your downloads, find it, and open that package. Then just let it continue with all of the automatic options. Agree, blah, 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 install, and then follow all of the instructions from there to let it install on your computer with the default options. Now you should be able to find R itself within your applications, and it has an icon that looks like this. But you're never really going to open R on its own if you're into using RStudio like I am and most people who use R are. So now that we've got R downloaded, the next thing is to download RStudio, and R is downloaded and installed. Okay? For RStudio, just go back to this Posit Site tab and click Download RStudio Desktop. Again, save that into your Downloads folder. Once it's finished downloading, go to your Downloads folder and just double-click on that DMG file. And then you want to grab this button, the RStudio app, and put it into your Applications folder. Now, you should be able to find RStudio by going to your Applications, and you can search for RStudio by starting to type in the name, and the icon for RStudio looks like this. Go ahead and open RStudio. The first time that you open RStudio, it may ask you where the R program is, but it will already know where to find it. It will just ask you to confirm, do you want to use that R program? Just say yes. Follow the options that RStudio suggests, and you should end up with R running within RStudio with no issues. Remember though, you now have two programs, both R and RStudio. If you just open R on its own, it looks like a much simpler program like this, but this is not what you want to use. You want to make sure that you just open RStudio, as you see here, and then you will have access to R from within RStudio. Okay, now I'm on a Windows machine. I'm here at the Posit site where I came to after searching for download RStudio, and I'm going to do this first button to install R. Just click that button, it takes you to this window here. Click the download R for Windows link. And then you have some more stuff here. Just go up to install R for the first time. Select that, and then at the top we have download R for Windows. Click that link, and when it prompts you where to download, save that to your download space. So it'll be this R whatever version -win.exe. So I've already saved that one here, so you'll click this save button to download that into your downloads folder. Then go to your file explorer, find your downloads, and just double click the R-win. And then just click yes and OK and follow all of the standard download options. Just click next, next, next until it's done, and then you'll have R installed. Okay, click finish when that's done. Now you've got R installed, so the next thing is to install RStudio. So we're going to go back to our web browser, go to the RStudio download site where we were previously, and click the Download RStudio Desktop button. All right, and then just save that again to your Downloads folder. Make sure you know where that's going. Just click Save. Once it's downloaded, go to your Downloads folder and click that RStudio installation file. And then just hit Yes and Next and finish until the thing is done. RStudio is a bit of a bigger program, so it'll take a little bit longer to install. When it's done installing, just click Finish. So now once you've installed those, you might see the R icon has appeared on your desktop. Now we don't want to use R itself, we actually want to use RStudio. So just go to your Start menu and search for RStudio. Just start typing in RStudio and then click the RStudio app. Now for the first time that you open RStudio, it's going to want to find the R program that you also downloaded because R will run within RStudio. So if it gives you a window that says, is this the R program you want? Just click yes. And then you'll open RStudio and it'll look like this with R itself running down here, but the rest of this environment is all RStudio. So R runs within RStudio. Here's what it looks like on Windows. If you just open R, then you see this program. It'll say RGUI in the upper left corner. That's for R Graphical User Interface. This is not the program we want to use. Close that program. Don't save. And just open RStudio. And that's where we want to interact with R. Now that we've opened RStudio, let's make our first R script file. So just go to the drop-down menu at the top, go to File, New File, R script. And now it opens up this upper left window, the script window, and you can see it says Untitled1. So let's write some comment by starting with the hashtag comment and code. So you can now write comments and code in your R script. Let's go ahead and save that. This is just like saving a document. So just go Save As, and then navigate to some sensible folder. Make sure that you're always working within folders and not from your desktop. For programming, for data analysis, it's really important to get in a good practice of organizing files in logical places within folders and folders containing other folders. Okay, for example here, I'm going to save this in R tutorials and then T0 for tutorial 0 getting started. And let's go ahead and call this file T0 getting started to match the tutorial folder. Notice that this is a .r file. That's the format of an R script file. Okay, I will save that there. Now the next thing that we want to do is make sure that we can open up .r files and they automatically open RStudio instead of R or the RGUI. So go to your folder where you just saved that script file, click on your script file, right click, and now go to Open With. Then if RStudio app is not showing as the default, go to Other, search for RStudio, and then you see RStudio app show up here, and make sure to check the box Always Open With. Now, once you select Open and that box has been checked, so we'll say Open, we've gone back into RStudio with our script open. Now, anytime I go back to my Finder and I just double click on the .r file, it will just open it right up in RStudio and open RStudio itself if it wasn't already. Now I'm in Windows and I want to make sure that our .r scripts always open in RStudio instead of R. So if you just go to your script file and you right click on it, and then you can say Open With, and if RStudio is not the default here, then go to Choose Another App, because it might actually just be R that's trying to open it, but you want it to be RStudio. So choose another app, and if RStudio doesn't show up here, well, if it does show up here, just select RStudio and check this box, always use this app to open R files. If RStudio doesn't show up here, make sure that box is checked and go to More Apps. And if you don't see it here, then go to Look for Another App. Your Windows version may look a little bit different than this, but it should be a similar procedure. So then you can search for RStudio and find the RStudio file. So I'll click Open, and now these .r files will always open in RStudio. Finally, let's just do a little bit of setup here before we get into calling in your own data set. If you want to look at a more advanced looking R script and even start to use that for the next tutorial and learn how to code in R, there is a link to a Google Drive folder in the notes underneath this video. And that folder will contain several tutorial files. So you can see here, if you go into the R1, the T1 R primer tutorial folder on Google Drive, it will contain these files. You can download that entire folder, make sure you unzip the folder, and then open the folder, and you can see these different files within it. There are 2 R scripts and a data set that we will use in a moment to practice calling in data into R. So for now, you can go ahead and select the script that says with code, R tutorial 1 with code. Double click on that. Now that .r files always open in RStudio, that opens right up in RStudio. So it'll look like this for you at the top. This script contains comments and code. So comments are just anything in writing that you want R to ignore as code, and then there's code that you want R to actually read and use as code. You might notice that this script file is neatly organized like a document, and all of the lines actually end at this vertical gray line that I have set up in my window here. Using that vertical gray line gives me an arbitrary endpoint, because your scripts can be as wide as you want them to be. But this gives me a constraint to keep my code and my comments all neatly organized and easily readable within the R window. That makes it much easier for me to troubleshoot my code and to share it with other people. It always ends up clear. If you want to follow that convention as well and set up this vertical line in the same place that I have it, then you go to Tools at the drop-down menu at the top, and you go down to Global Options. Then there are lots of things that you can set up here, but we will just go to Code on the left, and then click the Display tab, and check this box that says Show Margin, and then set your margin column to 90. Then you will have that vertical line show in the same place that I do. Scroll down and make sure that you hit Apply to make that change take place. Now, while you're in here, there's one more change I strongly recommend that you make. And if we're still in code and we go to the Editing tab, and then you see this option, Soft Wrap R source files. Make sure that that is not checked. I'll show you what happens when it is checked. So I'll check this box, and I'm going to hit Apply and OK. And now I'm going to drag the edge of my script window and start moving it over. And you see how all these lines start to get wrapped, and all these line numbers break up, and it shows that this is just a continuation of line 22 here, for example. This to me looks really messy, and it wraps your code as well. So when you have longer lines of code, it just wraps it onto multiple lines, and that makes it really difficult to read, because code actually, when it continues onto multiple lines, it becomes indented, so it goes down and moves over, and that helps you to see that you're still working within this block that started up here. When it soft wraps, you lose that indent, you lose all structure of your code, and you also easily lose your place. If I'm working down here somewhere and then I change the size of the window, then suddenly I don't know where I was. It just moved the window down to accommodate for all that wrapping. So you lose your place every time you move this window. So I suggest not soft wrapping, and instead keep your code relatively constrained with this vertical bar. So I'm going to go back to Tools, Global Options, Code, Editing, and then I'm going to uncheck Soft Wrap R source files, hit Apply, and OK. Now when I move this window, nothing happens to my code. I can still keep the place where I was working in the script, and my code is always structured and easy to read. Now finally, it's time to learn how to import your data into R to start analyzing your own data. So we're going to start with formatting an Excel file, turning it into a .csv file that's an easier file for R to read, and we'll call it into R. That sounds relatively simple, and it is, but there are lots of things that can go wrong if you don't know how to set it up properly. So I'm going to show you how to do that, and then after you've gone through these steps with me, you should find it very easy to do. Now, if you want to follow along with me and work and practice with the same file that I'm working on, you can go to the Google Drive link in the notes below this video, and it will take you to these folders. There's a folder T1 R Primer. Inside of this folder, there are a couple of data files and a couple of R script tutorial files. You can download the whole folder like this. Now, once the folder is downloaded, or if you get an option to find where to put it, do not leave it in your downloads folder. Put this somewhere sensible, like in R tutorials. Make a new folder if you need to. On a Mac, I just double-click this and it unzips it, and now I have access to the R Primer. On Windows, there's going to be this .zip file. You might not see the extension, but you'll see the zipper symbol here. So if you just double-click this, you can actually start working within the zipped file, but do not do that. This is a feature that Windows shouldn't allow you to do, but it does. R will not be able to work with files that are in a zipped folder, so it's important to unzip. So right-click on this folder and go to Extract All. Then just hit Extract and it will unzip this folder. Okay, so now we have this kind of repeated folder, so we can go in here and you can see that we have the T1 Primer. Let's pull this out, because see, it's sitting inside of this zipped folder name there. So let's just go ahead and pull that out by just dragging it up into our tutorials. Okay, so now we've got our T1 Primer folder. This folder is now empty. We can select both of these folders and just right-click and delete. Go into T1 R Primer and let's open up glopnet.xls. This is a publicly available data set, and this is a good example of the kind of file that you might start with in Excel. There's data in the file, but there's also what I call junk. There's stuff that does not allow the file to be easily analyzed with code. For example, all of these extra rows of header information at the top. So to set up a file to be read in R, you want to make sure that you have a perfectly rectangular data set. So it starts with a given row, and then if you go down to the bottom, there's an end row, and there isn't anything else in this data. Often what you will see in people's files is maybe they've put like the sum of a column here, and then they have these notes like total, and then maybe there'll be some graphs somewhere off to the side. What you want to do is get rid of all that excess junk, and it's not enough to just highlight it and delete it. If you've got junk in extra rows below or above, or columns to the side, what you want to do is highlight all of the rows like this that may have contained that junk, right-click, and hit delete or delete rows. Now that completely eliminates those rows. Otherwise, if you just delete the contents of the rows, then you'll end up with all these rows with just blank or NAs, because R will see that there was something there, and it won't see this last row as the end of the data set. You want R to see that last row of data as the end of your data set. Now, same thing if I go up and I go over to the right. You don't want anything else over here. Often people will make like these subsets of data. Maybe they've copied this and pasted it over here, and then they've got another one over here. So you need to get rid of all that by highlighting all of the columns. So you can just select one, hit Shift, and select more. And then delete those columns. So now your data file is truly going to end at this last column of data. Now we want to get rid of these extra header rows, so you can do this with me. Highlight all of these top rows above the column names, right-click and delete. Now our data set starts with the names of the columns. And then finally, we need to do a little bit of cleanup of these column names to make them easier to use within R. So people often put a lot of complicated characters in their columns, like this / and this apostrophe there, or quote. You need to get rid of all of that junk and turn the columns into something easy to read, and that can be read by R without any problems. The best thing to do is just take all of those and turn them into dots, like I just did here. So needle broadleaf, go ahead and change that / into a dot, change the empty space into a dot. Some people prefer underscore, I prefer dot because it's faster to type. You can quickly go through and change all of the empty spaces by just highlighting a row of column names, go Control F or Command F, and then select this ... go to replace, and you can say find what space, create an empty space there and replace with dot. So I just put an empty space here and find what, and add a dot and replace with, and go replace all, done. Now I've got one last thing, this dash here. I'll just get rid of that and make this just ca.ci. Okay, don't worry about what these column names mean. We're just getting practice cleaning up a file. So now our data is rectangular. It ends here, and it starts here. And if I go to the bottom, it ends here. It's okay to have empty spaces within the data. R will interpret those, and for number columns, for example, it'll insert NAs, and that's fine, so don't worry about that. These blank columns are okay because they have column names, so R will know, all right, this is data. There's probably some data somewhere in those columns anyways. Let's see, yep, there we go, down here, there's some data there. So R will interpret that empty space. We just want to make sure that it has headers going all the way to the end of the data set. Now, we're going to save this file as a comma-separated values file. It's a simpler file. It's basically just a text file, but it's one that you can also open easily with Excel to look at it. So we're going to go File, Save As, and we will select comma delimited CSV.csv file in the file format here. So again, that's down here in file format. Just go save as .csv and then hit save. And I've already got glopnet.csv in there, so I'm not going to replace it. I'll just hit cancel, but that's how you would do that with your own file. Okay, so now we have glopnet.csv. Let's open up glopnet.csv. Just double click on it and it will open automatically in Excel. Ignore these stupid warnings that Excel gives you. And you can see our data set. This data set is now ready to call in, and in fact, Excel already filled these blank spaces you can see with NAs, which is fine. There's just a couple final tricks here for file management that are really important for you. So one of them is that you can see on my computer, we can see the file name is glopnet.csv. And then there's glopnet.xls. On your computer, if you haven't set this up, you might just see the names glopnet. And that's because on my computer, I have told the operating system to always show me file extensions. This is important because you need to know when you're working with the CSV or the XLS Excel file. So, on a Mac, to do that, you open a Finder window like this one, and you go up to the Finder drop-down menu, Preferences, and then in Advanced, make sure that Show All File Name Extensions is checked. So you want to make sure that box has a check. Now you'll always be able to see your file extensions. To see your file extensions in Windows, you just go in your Finder here to View, and then you're going to see some checkboxes. Click the checkbox by File Name Extensions. Once you select that, you should now always be able to see the extensions, the .csv, .txt, etc. at the end of a file name. Second, when we call our files in to R, we need to be perfect with our spellings and with our file locations. So if you, for example, have downloaded glopnet.csv from my Google Drive folder several times, you might have one that looks like this with a 1 or a 2 in it. And when we go and use the code that I'll show you to call it in, R will not be able to find it because the name needs to be perfect. So if any of your files have this 1 or 2 like that afterwards, delete that so it just is glopnet.csv. That's the file that we will call in. Then finally, make sure that glopnet.csv is in a folder, not a zipped folder, not your desktop, not your downloads, in a folder like this, T1R primer. And it should be in the same folder as these R scripts, or at least if you're doing this on your own, you should have a CSV file in the same folder as an R script that you're going to practice with right now. So for example, if you made this T0 getting started folder and this R script when you worked with me to open up RStudio and make your first script, and if you want to work within that script, then take your CSV file wherever it is and move it or copy it with Control-C, Command-C, and then Control-V. Okay, now we have a file here. This is just to practice. I'm going to show you an even better way to organize your files and call them in, but for the first practice, I'm going to show you how to do it when they're in the same folder. Okay, let's go into RStudio to practice downloading a file. I am going to work within the T1R primer folder and within one of these tutorial files. So if you want to work with me, then in the same tutorial file, you can open up this RTutorial1 blank. This is the one that doesn't have the code already completed for you, so that you can just follow and type what I type. So I'm going to open up this tutorial1 blank. You can just use a blank script if you want to, or you can download and open up this same tutorial file as well. If you're working with me in the blank tutorial file, we're going to scroll all the way down part 8, somewhere around line 700 of this script. This section is on importing data as data frames. Okay, so we've already talked about how your data sets must be clean and tidy to import them into R. And they must have one header row with simple column names. We did that. They should be one rectangular contiguous, that means no blank gaps in between, data set. And most people will use .csv like we just created. Now, the first way to call in your data into R is to use a working directory. A working directory tells R where to look for your files. This is the easiest way to do this for your first time. Let's follow these instructions. We'll just go to the RStudio drop-down menu, go to Session, Set Working Directory, to Source File Location. The source file means the location that contains this script. So because I opened this script from here, from T1R Primer, the source file location is now the location of this script. And you can see that when we clicked those buttons, R showed us the code down here in the console. If you want to learn more about the details of RStudio, running code, all the basics of coding, everything else above this point in this tutorial teaches you all of that, and you can find a link to the full playlist with my tutorials down in the notes below this video. You can also send me an email at earth.operations.r@gmail.com if you'd like to know when any new tutorials drop on YouTube, or if you would like access to an online course when I've got that running. But for now, notice that when you clicked Session, Set Working Directory to Source File Location, R executed some code down here, which set the working directory for you. You can, if you want to be able to run your whole script and use that same working directory later, you can just copy that, and I'm going to put it in here under 8-1.2 and paste it there so that now I could just execute that line of code from my script to set the working directory for me. The way you execute code is just click anywhere on the line and hit Control-Enter or Control-Return on a Windows machine, or Command-Enter, Command-Return on a Mac. That's it. Put your cursor anywhere on that line, Control-Enter, Command-Return, and it executes that line of code and shows it to you down here in the bottom. Okay, now let's finally pull in our file as a data frame. So now that our working directory is set, R knows where to look for the data when we ask it to pull that data. Let's just skip to the fastest function here. We can use read.table, but there's a function specifically for read.csv, for reading CSV files, and that's read.csv. So what we're going to do is call the data from the file and put it into R, and we need to give it a name to store it in R. So we're going to start with naming it. We'll say glop, G-L-O-P, and you can just type after me down here in line 8-2.2, or work with me in your own script. So just type glop, and now we make this arrow sign with a less than and a dash. And that is the function assign. So we're going to assign the data to this name glop so that it has an identity within R. Now we type read.csv, open parentheses. Notice how RStudio automatically closes them for you as well, which is very helpful. Now we'll type file equals quote glopnet.csv, the name of our file. And that's it. Now just hit Control Enter or Command Enter, Command Return, depending on Windows or Mac. and you'll see that it executed this line down at the bottom. There should have been no errors if your file is in the working directory that you just set, if it's in the same folder as the script that you opened in RStudio, and if you spelled the file correctly here and the name exactly matches that in your real file here, then everything should have worked fine. If you did get an error, just follow the previous steps that I showed you. Again, make sure that your files are all in the right place and that you've opened a tutorial from the place that you think you did. Now, once glop was read in, if you look in RStudio in the upper right in the environment, you click the environment tab and you should see this item glop. If you click on glop here, it'll show you glop like a spreadsheet in the normal format that you're used to seeing it in. Another way that you can take a look to make sure that it was called in okay, we'll just go down here into the console and type head space parentheses glop and hit enter, and now it will show us the first few rows of the GlopNet dataset. And now you have finally set up your R and RStudio and you've pulled your data into R. You're ready to go. All you're missing is learning how to speak the R language. But don't worry, because I have more tutorials to help you learn the language, and I make them really easy for you. All you have to do is type what I type, follow along in the blank version of the tutorial script like you were doing just now. If you want to follow me in my next tutorials, find a link to the playlist of my tutorials. You've already got this script downloaded if you did that part, so you can go ahead and start tutorial number 1 and get into executing some basic code. The first thing we'll do up here is, for example, some basic math, and we go from there, and I teach you all of the important pieces of coding language that you need to know to analyze your own data. Congratulations for taking this first step on your R journey. If you would like to be the first to know when more tutorials drop on YouTube, or if you'd be interested in an online course offering, then you can email me at earth.operations.r@gmail.com, and I'll let you know about new tutorials and online courses. And if you found this tutorial helpful at all, please give the video a thumbs up and leave me a comment about what you found most helpful or what was most confusing for you. And that will help me to make these tutorials better for more people in the future. Thanks so much for watching, and I'll see you in the next R tutorial. Peace.